Great, so we have two speakers tonight. First, Marianne Bellotti is going to talk about Exversion.
So I want to talk about our startup bus project. My name is Marianne. My Twitter handle is Belmar, and like 5 minutes before this, I figured I really should put the URL of the actual project. So that's exversion.com. Because this is a startup bus project, I decided to title this presentation "2 Girls, 1 Bus." There were 3 of us. By the way, if you ever want to be discouraged from making a cheap and tasteless joke, asking people who voluntarily got on a 3-day hacking road trip with you is a bad call. They will not discourage you. So anyway, Exversion is all about data, and open data is awesome. It takes like normal people and it makes them 10 times as awesome as they were before. But open data also kind of sucks. It's just a total nightmare in terms of formatting and standards and finding it. And we thought, well, as we were on the bus, we should make it not suck, because that would be awesome. So what we came up with basically comes down to 2 main features. The first one is having an actually usable API for data sets. I don't know how many of you are familiar with the state of open data right now, but most of the time when you go looking for an open data set, they'll be like, here's an Excel file, go develop on it. Or here's a CSV file. You don't often have an API, and if you do have an API, good luck with it. It may not be very restful or very nice to use. The second feature that we were really interested in is versions. This idea of we can take what GitHub does for source code and maybe do something similar for data. The reason why we want to do this is because when people collect data, they use a particular classification framework. They decide how they want to decide what data points are what. And that doesn't always fit your needs as a developer. So you should be able to remap it. And once you've remapped it, odds are probably you're not the only one who has these needs. So you should be able to share it with other people. The classic example I use is a couple months ago at a company I was working for, one of the senior engineers gave me this. He's like, this is what the API for the Department of Education is returning. No idea what it is? Do you have any idea what this is? There's no like guide for all these bizarre looking call numbers. And so I sat down with it for a minute and I started to see a pattern. And I realized that actually they had broken down the demographics by race, by gender, and by age. So this number is, there are exactly 3 Asian male 9th graders at the school. So we looked at this and we're like, we have to fix this. So we ended up remapping it because odds are this level of granularity is probably not very useful. But at the same time, it might be. I don't know. Maybe there is a situation where you need to know how many 4th grade Eskimo females there are at a particular school. So anyway, we got on the bus. And initially, I didn't want to build something that was too complicated because we only had 3 days and I was the only engineer. So I was like, fuck it, I'm going to do it all in PHP. Because PHP is awesome for websites. It is awesome for websites. I love Python. I'm sorry to Ruby people. PHP is awesome for websites, but kind of sucks for everything else, including processing data, especially large amounts of data. So I had done this before with another project, so I kind of knew where the pain points were and how to avoid it, but it became very clear that if it was PHP only, it was going to severely limit our ability to handle anything over 1 kilobyte, basically. So then it became a question of, okay, I'm going to rebuild the data processing backend, Python or Clojure. Obviously, since this is NYC Clojure, the answer was Clojure. The main issue was Python is really, really great for data. It's like the default language of data science, but when the type of processing that we need to do is not going to involve a lot of libraries, it's not going to involve a lot of calculations, it's just basically taking the data in a raw format like a CSV file and moving it into something that's queryable. And I was really interested in the advantages of multi-threading, and Clojure is really good at that. And I really love Clojure. This is actually, by the way, the 3rd thing I've ever built in Clojure. So when we look at the code, maybe we'll have some fun with that. Anyway, so basically the state of it now is, as much as I love Clojure, Clojure's web frameworks are not very well developed. And you're going to hear another speaker about that, which makes me really happy. So PHP is still awesome for web, but Clojure is going to handle the data. And they're going to communicate through basically just a Postgres table. You're going to build a queue in the database, and PHP uploads the file, puts the URL of the file into the queue, and then Clojure accesses the same database, grabs the file, streams it from the URL, and does its business. So then there became a question of when did we bring in the multi-threading? I was very inspired by Widefinder, the Widefinder challenge. I thought it was neat. It was really cool how he optimized it to go super, super fast. But the thing about Widefinder is that, for those of you who are not familiar with it, he takes a huge, huge file, I think it was like 45 gigabytes, and he cuts it into pieces, and then he processes all the pieces in parallel. This wasn't going to work in our case because, one, we're dealing with CSV files. The first line is the header. We need all those keys. And the second reason was we're streaming it, and there may be a way to cut a file that you're streaming from a URL, but I couldn't figure it out, so I was like, we can't do that. So what Exversion does is it actually splits the lines and then runs the lines in parallel instead of chunks. And this is basically what that looks like. The first part of this is just standard Java I/O, pulls the file and streams it. And then we get to the fun stuff, which is the first thing we have to do is isolate the first line of the file from the rest of the lines. So that was pretty straightforward. Fun. And then once we've done that, we want to check to make sure that the formatting is what we expect it to be. Because those of you who think that CSV stands for comma-separated values are wrong. It actually stands for common standards are completely variable and totally optional. So the classic CSV, the one that I like, is comma as a separator, go figure, and then new line with an actual new line character. But sometimes people use a semicolon, sometimes people use a new line with a return. Sometimes people use a tab, which drives me crazy, and I hate so much. But whatever, all of those are fine because every CSV parsing library will have an option to change what the separator is. What's not fine is when people use line breaks inside of values for no reason, when they use values with commas but they don't quote them. And my personal favorite, this is something that Excel does when you convert an Excel spreadsheet to a CSV file. It goes, hey, let me just add a whole paragraph of text in the beginning of the file for absolutely no reason. And those things really screw up the design of this kind of processor because you just can't control for them. So what I decided is, okay, I'm going to make it so that it checks the first 10 lines of the file, and if it sees that there's like massive inconsistencies, it just flags the file as there's an error here, puts it back in the database, and then maybe I'll go in and clean it up, maybe I'll just send an angry email to the person who uploaded it. Who knows, haven't decided just yet. So what this little chunk of code does is it basically takes the first 10 lines, it counts the number of items, it counts the number of keys, and then it compares the number of values in the first 10 lines. And if within the first 10 lines there's a mismatch, there aren't the same number of values as there are the same number of keys, it just throws it into the database as an error. If it does, it returns true. This is maybe not so Clojure-ish. I wasn't quite sure because I was looking for how do you return true and how do you return false in Clojure, and everyone was like, you don't. You just, there's no way to do return true. And so I was like, I don't know if I'm really supposed to do it this way, but what the hell, it works, I'll do it anyway. It might be okay. I'm not really sure. So someone correct me, please, if this is the unclojure-like. So anyway, the report function is just basically call Mongo, update the listing with the appropriate information. That's kind of boring. So anyway, assuming that everything checks out, everything runs fine, now we have to convert it into a Mongo document. So first thing, we need things that are not in the CSV file. First we need an ID number for the document, and then we need this sets. So we add the keys to the header. And the reason, this is where things get fun. And initially, when I did for Startup Bus, it was all basically running on a relational database. And when we wanted to upload a new database, it would just create a new table dynamically. It'd be like, these are the columns and these are the rows. And that was wonderful, except that somebody was like, well, okay, but what if I want to remap your data and I only want to change like 1 or 2 rows? Then you have all this duplicated data. It hasn't changed, but you're storing it twice. And that was something I hadn't considered at the time, and it really irritated me that I hadn't considered it. So I was like, we can't do this. We have to change something. So the original model was to sort of use MySQL to dynamically create the tables. But in order for that to work, all the data has to be in the table in order to query it. So I moved it over to Mongo because it's documented oriented. And by having a massive collection, all the data can be queried just as long as it's somewhere in the collection. So what this means is that if this is a data point, every data point will have an array of sets, basically data sets that that data point belongs to. And if we have a duplicate data set, rather than writing a new document, we just add another data set ID to the set. So now I can query this just by saying, I want this data set and I want this little piece of information. So, and then the last thing it does is it runs the lines in parallel and basically creates those documents. This is really cool, pdosync. I didn't write it, I can't take credit for it, but it's really awesome. This was I don't know how to pronounce this last name, Cedric Gravy, I think, Gravy, something like that. Anyway, I found this through excessive Googling, and I was like, that's awesome, and I sort of understand what it's doing. It's just basically running dosync in parallel, which I thought was awesome, and it works pretty well, so this made me happy. So then it basically inserts the data, and that's what's going on here. The first thing it does is add, so we added 2 keys, now we gotta add 2 values. It creates an ID for Mongo. Theoretically, Mongo will actually assign an ID automatically, but the query one's much faster if you don't ask it to do that at all, because it has to be unique. So I basically generate a random number, get the original dataset ID, and then add the date to the millisecond. And I figure that's probably unique. I'm pretty sure, like a number between 1 and 99, the odds of even running in parallel, coming up with the same ID are pretty astronomical. So then once it's put those values in, it now creates a zip map, which was my new favorite function. I was like, this is so cool, why doesn't every language have a zip map function? You give it your keys, you give it your values, and it's just like, here's a map with all your keys as keys and all your values as values. I was like, this is the most awesome thing ever. But because, again, nobody formats CSV files really the same way, a lot of times people will add really bizarre things. So just it very quickly cleans the headers first to make sure that there are no special characters. It converts spaces to an underline, and it trims it of any white space just to make sure that we don't have any issues in that regard. And then just really quickly, it does a query to see if the data is already in the database, and if it is, it dissociates the ID and set and uses the data to isolate our document, and then it pushes the new data set ID number to that document. And if it isn't, then it inserts it. So that's about it.
Question.
Yeah.
Sorry. There is built-in functions in Mongo to import the CSV file if it is conforming to the format. And why not just use that built-in Mongo import function instead of doing that insert in Clojure?
I looked at it, and I believe that it has to be run basically from the terminal rather than from a program. So that would mean I would have to tunnel in to the Mongo server and run that command. And also, then I wasn't sure how it would handle duplication of data. Whether it would just go, okay, all these CSV, dump it in. And I felt like it would be more efficient to do it this way.
So can you go over that set thing again? So you had one record per CSV row, or document per CSV row, or?
So one row in the CSV is one document.
Okay, and then so for when you duplicate data, you have the set IDs for every set that row ever occurs in?
Yeah, basically.
And how do you establish the set the data point exists in multiple sets? Like when you encounter another Marianne Bellotti Exversion data point, do you query the DB for those three fields?
Yeah.
Okay.
Have you considered using persistent data structures?
Such as?
Like, rather than annotate every record from every sentence in for encoding incremental changes?
I've thought about it because we use the GitHub example a lot when we pitch, and it would be neat to do it in a slightly more efficient way. I just haven't quite figured out what that would look like. So come see me after, tell me what it will look like.
This might be a dumb question. What do you think about Datomic for this use case?
You know, I was talking about this with somebody, and I was like, I can't quite figure out Datomic. You know, I wanted it to be document based, and my understanding is Datomic is really kind of more of a layer over a database.
It's more of a value based.
Right. I wanted to stay away from key values as much as possible because I've had trouble.
Well, let's talk after.
Okay. It's gonna sell me on Datomic.
Yeah, you gotta take a check out Datomic.
Okay.
You got it.
It's actually exactly what you want.
Really? Oh. It's a good thing I went to the Clojure meetup then. That's why I come here. Oh my god.
I work for Datomic, so.
Yeah. Do you know how much code I'm gonna have to rewrite now? Damn it, people. Yes, Sebastian.
So part about dynamically creating the MySQL tables, can you just go over that again or explain what? I mean, I understand the concept of dynamically creating tables. I've done that, but
It was really cheap, dirty hackathon style hack. We basically it's completely gone now. But the idea of it was identifying what the keys were and just basically generating a SQL query as a string and then running it in the database.
okay, so it just felt, it wasn't that it didn't work or scale or whatever, it just felt.
The scaling was kind of questionable because it was like, okay, in theory it would probably scale, but you are duplicating a lot of data, which means that you're getting closer and closer to that point where you have to shard things without necessarily needing to be. But it worked fine, I mean, for the demo.
This is kind of more of a question for the room. Does MongoDB do compression or compaction of keys?
No.
No? Because I know that used to be a problem.
It used to basically do none. Now it does. Now it does more.
It does more. So
What?
what's more?
More than none.
So like if you had like a million of these, not every record would have name, Twitter, company sets.
And some percentage and less than a million. Where I
Okay.
don't know off the top of my head, but if you
Okay.
look it up, it's a recent thing that they questioned.
Okay.
It used to be a thing where duplicate keys just took up duplicate space.
Right.
But they figured out a way to reduce that footprint.
Awesome.
But it's not as drastic as like Lucene or something like that that has much more sophisticated compressions.
You guys are all so much smarter than I am. It's very sad.
Just older, not smarter.
Nobody else wrote that, right? Well done.
Great hack.
Thank you.
All right.